We're going to cut the pieces of Delrin rod that are going to become the lead screw nuts after we drill and tap them. We're going to need 3 of these, and 2 of them, which are the X and Y, can be, this actually isn't a terribly critical measurement. It can be approximately an inch long or so. An easy way to just get a mark all the way around here so you can guide yourself is just to rotate the rod while you're holding it, or while you're holding the pin on it, and that will just give you a mark. So we want a couple an inch long, and then the third one is the Z-axis lead screw nut, which of course goes inside this piece right here. So if you make it, it's going to be about ½ an inch long. If you make it too long, then it's going to have to stick up a little bit, which, you know, might not bother you. But it does not have to be as long as the other ones. So after you've made a mark, I'm just going to demonstrate cutting one of these. You have a vise, which for portability we've just clamped ours to the table. This also has a set of vise jaws, which are very handy, and I would recommend them. They just have cutouts in them which help you to hold things level and securely. Now I'm demonstrating cutting the Delrin rod with a hacksaw with a fine-tooth blade on it. Obviously, if you have a bandsaw that you're making your pieces with, that's also an option. Just remember that if you're going to use your bandsaw to cut the Delrin, you've been using a wood cutting blade to cut the body pieces. Those are generally coarser teeth, and you can't be using a coarse tooth blade on this Delrin. It will probably snap the blade when it hits it. So you want to use a fine tooth blade like a metal cutting blade on your bandsaw if you want to cut this Delrin on a bandsaw. Okay, so I've left just a little bit sticking out here. I'm just going to cut a 1-inch piece off. Start it carefully. Okay. And it's going to go through pretty quickly. This is a pretty soft plastic. There we go. Pretty soft plastic. And that's another one of our inch pieces. And we'll just cut the ½ inch piece, and then we'll see about drilling and tapping them. This is one of our lead screw nut blanks made out of that ½ inch Delrin rod, and we're going to drill a hole down through it, through the center. The exact centering of it is not critical because this piece doesn't actually have to rotate itself. It's going to be moved until it aligns with the lead screw nut distance from the plate you're epoxying it to, and then it will be epoxied in place. So a little bit of off-centering is not going to be a problem. How you find the center is up to you. I happen to have this jig I got from, I think, Harbor Freight a long time ago, which is just a centering jig for doweling. It's got a ½ inch hole here, and I just put it in there and tap it, and I've got a little dimple in the center. But you could also do it just very carefully with, you know, a ruler, 1/4 inch this way, and just keep rotating it, and eventually you'll find the exact center, and just put a dimple there with a nail or a center punch, and you can drill your center. The other thing that's extremely helpful to have is a pair of vice jaws, which are a little more rigid. These I actually printed just because, you know, I had a 3D printer, so I just made some V-blocks. It's called, you know, V-block vice jaws, or whatever you want to call them. And they just have a vertical set of notches in there so that when you put in a piece of round stock like this Delrin, it's just going to hold it exactly vertical, and so that the hole you drill will be normal to the Delrin rod. So I've got this about a 1/16, I think, inch bit in here, just that we're going to try our pilot hole with. I've got it clamped in the V-block, and of course I've taken the drill press vise and clamped it to the bed, and the bed is clamped, and the bit is just above the dimple. So what I want to do is visually check it in 2 directions. That's, if it's not quite right, very gently persuade it. That's about right. Okay, that's right in that direction. Nope, a little too far. That's good in that direction, and you want to check it again at 90 degrees. Okay, so it looks like we are dead set. And if you have a laser and you have it aligned where you trust it, you can also use a laser alignment tool if your drill press has one. So switch these out for safety glasses and very carefully drill this out. So I checked that this actually was properly aligned, and I took out the little pilot hole bit and I put in the actual size that we want to make the hole that we're going to tap. The nominal size for that 3/8 by 12 inch Acme tap is a 7.6 millimeter drill bit, but a 19/64 is extremely close. So you can actually get a 19/64 inch bit fairly easily. And that's what we're going to drill out this Delrin with. So I've swapped out the bit for 19/64, and it's going to bring this up almost to tip again so we can see what we're doing and lock the bed down. And again, just because we've moved everything, I'm going to double check my alignment. That's a little off. It's a little gentle persuasion with these clamps on it. Right, dead set on the pilot hole tip, or pilot hole, and check it at 90 degrees, and just as visually as close as you can get it. And that looks dead center right on the pilot hole that we drilled before, and it's in the same clamp, so we should be good to go. So swap out for my safety glasses and drill this out. Okay. And we should have a hole now that we can use. And it's a little bit, just the tiniest bit off center, but again, without a lathe, you're not going to get it perfect. And for the purposes of this piece, again, because it's not going to rotate, the absolute concentricity, you know, a completely centered hole, concentric with the outside of the rod, really isn't critical. So that's one, and we will just be doing that to our other two lead screw nuts as well. And now I'm going to show you how to tap it. And this, of course, is all in case you end up you know, knowing that you're going to need a bunch of these and you want to make your own instead of acquiring your lead screws from somewhere else, or lead screw nuts from somewhere else. So you're going to have your Acme thread tap, and you're going to have a tap wrench, which of course, you know, just holds it. And if you look at this V-block here, this is not the plastic one I had. This is to demonstrate how you can actually make a V-block pretty easily on a bandsaw with these two identical pieces of wood, and you just draw your 45-degree angle, and you can use something like a small, you know, 45-degree angle on a square to get these cuts. And so what you have here is a square bisected by the line between the two pieces of wood on the diagonal. And again, that's just an ordinary V-block. If you can buy one instead, it'll be probably more precise and hold it more securely. But if you have to make one, you can see how that works. So its point is to hold round stock securely, and of course when you're using it for drilling, it also holds it completely upright and at 90 degrees to the bed, or 90 degrees to the vise, I should say. So we're just using it here to hold this round stock for the purpose of tapping. So I'm just going to put it in here so I can get to it and just tighten it up just snug so it will hold it while I'm tapping it. Now this Delrin AF, this is, you know, Teflon Delrin material. It has a pretty low coefficient of friction, and you're not going to have to be as careful as if you were actually tapping metal. But so for instance, you don't technically need any lube. on it, but it's not going to hurt anything to have a drop of oil or two on the flutes here to help you do this. And likewise, when you are tapping something that's, aluminum or steel, there's a process by which you go forward a turn and you back off and then you go forward again. That's because you're accumulating a chip, a long chip that you're shaving off the inside, and you're breaking that chip. If you don't do that with metal, eventually you'll get completely bound up and it'll be stuck and you'll break your tap or you'll ruin your piece. And that's why you back off after every turn. But again, for Delrin, probably not a big issue because you're probably going to be taking it off in smaller pieces, but still, it's not a bad habit to get into to do that reversal. So it's upright in the V block. You want to put your tap. This tap is tapered. The first part of the Acme tap just cuts threads, sharp threads, and then the second part of the Acme thread comes in and cleans up those sharp threads and makes them trapezoidal to match the Acme rod. So you want to hold it as much as possible at right angles. So you want to check that in two directions. I'm at right angles, and provide a little downward pressure while you turn, clockwise of course, because we're doing regular right hand thread here. And you want to get it in until you feel it start to bite. And now, as you push down, you turn it about a turn and then back off just a hair. And then turn it again, about a turn, then back off a hair. And again, if you were doing metal tapping, when you backed it off, you would actually be able to feel it snap that chip. But in Delrin, it's not going to happen so obviously. You can actually, even with the Delrin, you can feel it starting to move a little in the jaws there. You can actually start to feel it bind a little bit right before you back off, because you are getting some stuff accumulating in the teeth there. Okay, we're now fully, the tap is starting to protrude out the bottom, the tapered portion. So we're in several teeth now. So you don't actually have to push down at all. You can just turn and it will pull it in. And at this point, I realized that I forgot to do something important, which is that you do not want the tap in line with the main screw of the vise here, because we're going to hit it because this tap is so long. Ordinarily that wouldn't be such an issue because you wouldn't be going through that long. So, but I'm going to move it over to the side so it'll be out of the way of the screw of the vise, because this is an extremely long tap, much longer than most of them. Okay, so let's get that evened out again. Okay, now we're out of line with the screw. And I wouldn't want to do that movement at the beginning, but again, since we're now fully trapped in there, it's not an issue. So I'm just going to turn it, back off, turn it, back off. And once you're completely through, it's not like you're building up a great deal of a chip anymore. You don't have to back off. You can just keep screwing it through. And by the time this exits out the bottom, these Acme threads up here are going to have caught. And they'll just continue down. And as they start to widen out, the tap will start to clean up those sharp threads it cut. And I can feel them starting to scrape now. And they'll turn those sharp triangular threads into trapezoidal threads that will engage the Acme rod. And we're just going to go all the way through. And of course you didn't get big chips on this because it's not metal. You get more plastic shavings than anything. And then once you're all the way through, you can just very carefully back it out. Okay, so there's a lead screw nut, and you want to take this and take your piece of Acme rod, which you can see I've already threaded a couple of these onto, and you want to evaluate your lead screw nut here by screwing it on, and it should go on pretty easy. If you have to turn it on then hard, then obviously there's something wrong with your lead screw nut. But this goes on smoothly. There's not a tremendous amount of resistance, but it's quite snug because the Delrin is actually grips the Acme pretty well, and that prevents backlash. And if you feel it, there's no rocking, and if you pull it longitudinally along the axis, you feel nothing. But it's not like I have to grind it on. So this is a really good nut. It's nice and secure, no backlash, but it's not terribly tight. And if you look at it, as you can see, it's not really, the hole is not really concentric with the outside of the cylinder, but again, that's not an issue. This is going to be epoxied in place at some point along the rotation, which will give it the exact height that you want, and then it will stay there for good, and the lead screw will run it back and forth. So that's a good nut. You're going to make 2 of them that are 3/4 of an inch long, and one that is about 1/2 inch long. With the 1/2 inch long one, there will be a moment where, as the sharp threads are exiting out the bottom, the Acme threads are only going to have a couple of thinner or lower diameter threads beginning to catch. And so you want to make sure in that transition moment that you guide it very carefully so that your Acme threads don't get cross-threaded with the initial sharp threads. There are also some Acme taps that just do it in one pass. There's just one set of threads that cut Acme threads right at the beginning. And it just depends on which style you get. But you will, just because there are fewer threads along its length, have to be more careful and more diligent about cutting threads in your 1/2 inch one. So that's making your lead screw nuts with an Acme tap. We're going to talk now about cutting your actual Acme lead screws. And the length is a little bit of a consideration, because in the original design, the idea was to use a lathe to bore out the end of the lead screw to fit this 5mm shaft on a stepper motor. And there's a little bit of a problem like that with that, because we're trying to get through this build without using that kind of equipment. And so to look at it from this perspective, if you bring this up here, you can see we have this, we've already mounted the motor temporarily, just sticking through here so I can see the length. We're going to slide this lead screw in here, and we're going to assume that the coupler you're going to use, and we're going to go over some different coupling options, we're going to assume that the coupler is going to butt these up end to end. And you'll notice that even if the coupler comes over to here, there's still all this room over here to be putting your actual lead screw nut, which you're going to epoxy on the back here. There's plenty of room to put it in. So again, there's not really tight quarters here. You've got a bit to play with. On this end, so we're going to assume that we're going to butt it right up against the end of the stepper motor shaft, and we're going to assume that it's going to come all the way out here. You also have the option, if you care to, of actually adding an inch or so onto that length, because you do have some extra length. When you buy a 3-foot piece from McMaster-Carr, you're going to have some inches left over. You could actually have this sticking out an inch or so, and then you could either manually, or say with a piece of, you put a piece of vinyl tube on it, or print a knob or something like that, and then you can use it to, when it's not energized, you can use it to manually rotate the knob with your fingers and move this would be the x-axis, back and forth, so that you can, say, precisely zero it to a particular point if you want to. You can also do that with the electronics and software that we're going to demonstrate, but you might want to consider leaving that little bit out there. Otherwise, you can just reach in and grab it by the middle. If you do leave it sticking out, remember that, you now have this lead screw sticking out here, and it's subject to getting hit. So it depends on, if you want it more mobile, you probably want to leave it, still flush with the end or inside rather than sticking out. It really depends on your application. But I'm going to consider that we're just going to leave it flush with the end, butted up against the stepper motor. I'm going to temporarily stick a piece of tape on here. And we are going to just roll this tape around the rod for the purpose of getting our cut started. So I'm going to cut obviously to this end of the rod. It's going to be a little bit of difficulty when we get started because of course there's a beveled or an angled thread on here, and that's going to try to grab our cutting wheel, but we're just going to have to get past that.
The rod's also going to heat up quite a bit as we're cutting it, so after we get it started and we know what we're doing, probably stop and take the tape off before it can start to char. So we've got this clamped in the vise, and I've got my tape mark here that I'm going to cut to. Notice that I am using some vise jaws in here. I'm using my really nasty old ones in case this gets hot enough to do a little damage to them. It would be nice if I had some wooden or steel ones, but you know, this is what I got. So I've got it clamped in, this way it will not tilt as I'm applying pressure. This, of course, is a right angle grinder, got a cutting wheel on it. If you should be familiar with this before you use it, but you notice it's going to rotate this way, and so you give some thought to where sparks are going to go. They're going to be coming down, a little forward, down, and the shield, of course, is going to be catching them from going too far behind. In our hacker space here, unfortunately, we have this nasty old carpet, which they said we could pull up, but I still don't want to be spraying hot sparks all over it because they'll want to know why there's burn marks on the floor. So I've got an assistant here, a trusty videographer. He's just going to hold a cardboard box under here. It's not going to set it on fire, it's just to stop the hot bits from damaging the floor, which, as I said, it's unfortunate that we have carpet. So you also don't want to be getting online with it because then you're just eating a bunch of sparks yourself. So you want to get offline, plus then you can see what you're doing. And I got a two-handed grip on it, and I'm just going to start cutting through this. Make sure also that you know exactly where your cord is. Just like with a circular saw, you don't want to be having the cord cross your line of cut. You want it off to the side because you don't want to be able to cut into it by accident. That's just a really good habit to get into. So I'm just going to cut through this real quick, and of course we're both wearing safety glasses. I'm going to get it started, and once I get it started well, I'm going to stop. I'm going to take the tape off before it starts to char or burn as this gets hot. And then at the very end, the assistant is also just going to catch this so that it doesn't dangle off and then fall. So here we go. Okay, if I can find the end on here, peel that off. Okay, and we're just going to finish up real quick. And that's it. This is a pretty good cut. You might want to take it over to a grinder or even with a decent file and just clean that up, because that last thread there gets wicked sharp right as the cut comes down. It enters it as a bevel. So you probably want to grind that off or file that off. Notice as it comes from McMaster-Carr, the end is already pretty well beveled for safety. So we're going to do the same measurement idea with the y-axis. Same idea. We're going to have the motor attached to the rear. We're going to have the shaft sticking through, and we're just going to measure all the way up to the front. Notice there is no hole up front, and so you're not going to have it poking through, unless for some reason you want to add a hole up there and attach a knob, but then again it's sticking out and can get hit. So we're going to do the same measurement and the same rod cutting on this piece, and as you notice, we've got good movement here from when we glued it many days ago. And in a few minutes I'll show you how to do the z-axis measurement, but right now I'm going to cut the y rod. So to measure the length of your z rod, we're just going to temporarily prop this up here. This is actually, of course, the plate you're going to screw onto this longer plate that you drove the T-nuts into back when you put the x-axis together. And where this is going to end up going, your z-axis motor is going to end up right underneath your upper level of sliding bushings here on the x-axis. And of course, the rod is going to go from here to here. And what you want is for this, and of course this is actually going to be up here like this. So you want this to be able to travel all the way up here and still have your Z, and still have the lead screw engaged. So you want it to travel from the tip of this all the way to when this is fully raised, by which I mean that's up there like that. So we want to temporarily put this up here and look at this distance here and measure this interval there. So I'm going to, there's also a problem. You want to hold that up there? Thank you. So this Z-rod is going to be, again, if you're butting it right up against the end of the motor shaft, it needs to be just about 4.5 inches long. So that's what we're going to measure it for on this. And there is a problem which we are going to, as we mentioned in the BOM, you have to make sure that this dimension on your motor, depending on how big the torque is on your motor, NEMA 17 motors get longer generally as they become more powerful and have more torque. So you don't want this dimension to be too great. We'll specify in the BOM what it can be, because if you look at this right here, as this is butted up against these upper bushings, there's really not enough room to put in a coupler, and even for the lead screw itself to ride safely under this motor. There just isn't enough room. And that's because when I did my first build of this mill, I had a lower torque motor on the Z-axis and it simply wasn't as long. So we'll be specifying this dimension.